Okay, Maito's back from a cigarette. Now we're ready to start. This is section 10.2 on circle geometry. We're talking about perpendicular bisectors. So Hunter, question 1 says, describe how you know that the diameter of a circle forms a right angle with the chord at the point of intersection. The answer to that is I know it's going to be a 90-degree angle because if this is the chord and this line here is cutting it exactly into two equal parts, the only place that could cross that chord is perpendicular to it in order to cut it into two equal parts. So therefore, I know that that diameter has to be crossing that chord at 90 degrees. Otherwise, it would not be two equal halves. Hence we can say, in order for it to be a perpendicular bisector, it has to be perpendicular, meaning 90 degrees, and bisecting the chord, meaning two equal parts. Question 2 gives us a circle, and it has two chords drawn. This is the first chord, and this is the second chord. And it asks us, how could you locate the center of the circle using those two chords? Well, the answer is easy. If you locate the middle of both chords and draw a little point, and then draw a perpendicular bisector all the way through it. Oh, that's not going to work, is it? Is that going to work? Well, it's not perpendicular, that's why. See, it's hard for me to see this because on my screen it's a circle, but it's really an oval. Something like this, perpendicular, and then middle of the circle, straight up through, perpendicular. Where those 2 points cross, right there, is going to be the middle of the circle. So where two perpendicular bisecting diameters cross, we'll always find the middle of the circle. Question 4 says CD bisects chord AB. So I'm just going to read this with my highlighter here. And right away, I look at this picture and I'm like, okay, if it bisects chord AB, I know that it does because it has these two little things. But what's omitted from that picture that probably should be included if it bisects it? A 90-degree angle, correct? So what I'm going to do is, because I read that sentence, I'm also going to put that in because that has to be true. If that radius bisects the chord or cuts it into two parts, it had to cross perpendicularly or at 90 degrees. So then I continue to read. It says the radius of the chord, or the circle, is 15 centimeters. So what that means is, if I grab my other highlighter here, my smaller one, if this is a radius, and that's 15, also AC has to be a radius as well, right? So it also has to be 15. So on my picture, I'm going to include that piece of information because the radius is 15. I'm going to actually write that in. Now this is important because if we think about this triangle that we have here, 95% of the time in this circle geometry, we're also using Pythagoras. So really what we've defined here is the hypotenuse of our triangle. And then the next sentence says, the chord AB measures 24 centimeters. So if this whole chord is 24 and it's been bisected, then how long, Hunter, is AE? It has to be half of 24, which makes it 12, correct? So before I do any math, I haven't done any math, I've just read, and I've put that information into my picture. That's what information I include in my picture just by reading the question. I don't even know what it's asking me yet. I just know that's the information. I've translated what's given to me, and I've put it into my triangle or my circle. And now I have my question. And my question says, what is the length of CE? And explain your reasoning. So what is the length of CE? How are we going to solve that, Andrew? Not a clue. Exactly. You're going to use Pythagoras. So right over here, I'm going to redraw my triangle. It's a right triangle, which is important because otherwise Pythagoras wouldn't work. A leg of 12, an unknown distance of CE, which we'll call x, and a radius, or in this case, a hypotenuse of 15. If I add my squares to each of the sides, like Pythagoras would have said, a squared plus b squared, a squared is 144, b squared is x squared, and c squared is 225. What number plus what number equals 225? The answer is this has to be 81, because 144 plus 81 is 225. And therefore, how long is x? 9. So if x is 9 on my triangle, then CE is 9 as well. And my reasoning, if I was explaining it, is explained quite neatly using the Pythagorean theorem. In our next question, we're going to try the same thing. I'm going to take my instructions and just read them. So the radius bisects chord HJ. So I know it bisects it because it's cut. The chord is cut into two equal parts. But what's omitted from the picture? Just like the last question, the 90-degree angle was omitted, isn't it? Because I know that chord had to cross, or the radius had to cross the chord at 90 degrees. Continue to read. It says CG measures 4 millimeters. So CG is this distance here. So I'm going to write in 4 right there on my picture. And then I'm going to continue reading. Chord HJ measures 14. So HJ is this. So it measures 14. So because it was bisected here, I know this means this is 7 and this is 7, don't I? All right? You with me so far? And then I continue to read even further. Sorry, that was this one. What is the radius of the circle expressed to the nearest tenth of a meter? So what is the radius? Am I going to use that green line, do you think, to figure out the radius? No, I'm not. What I am going to use, though, is this radius right here. Because if I use that radius right there and put x there, I have my right triangle again, don't I? 4, 7, x. Right? I can use Pythagoras to solve that. If I think of that triangle in terms of A, B, and C of Pythagorean theorem, which number or which letter do I not know, A, B, or C? C, the hypotenuse, right? So therefore, A squared plus B squared equals C squared is my theorem, or 4 squared plus 7 squared equals x squared, or 16 plus 49 equals x squared, or 65 equals x squared. So therefore, the square attached to this leg would have an area of 65. Now, if I square root both sides, a lot of you are going to jump to the calculator right away, but don't. Because what is the square root of 64? 8. So we know that the square root of 65 must be slightly more than 8. A best guess without grabbing a calculator would be 8.1. But we'll check our answer. What is the square root of 65? 8.06, which rounds up to be 8.1. So therefore, the length of x is 8.1, and therefore the length of chord CJ is 8.1 millimeters.